Good morning all. We'll continue our discussion on the first module and its numerical problems. Question number 4. A soil sample has a porosity of 40%. The specific gravity of solids is 2.7. You are asked to calculate the void ratio, the dry unit weight, and the unit weight at 50% degree of saturation. The question is quite simple. You are given with the porosity 0.4 and from which you can find the void ratio, because we know the basic relation n is equal to E by 1 plus E, in which n is already given as 0.4. So once you cross multiply, you will get void ratio, the value of which turns out to be 0.67. Now the second question is to find the dry unit weight, or gamma d, which means S degree of saturation is equal to 0. So from the basic relation, we know that gamma d is equal to G by 1 plus E multiplied by gamma W, in which G is already given in the question, 2.7. E, the void ratio, is 0.67, which we have found out a few steps back, and gamma W is equal to 10 kilonewton per meter cube, or 1 gram per cc. So once you substitute these values, you will get the dry unit weight approximately equal to 15.89 kilonewton per meter cube. Now if you prefer to use 9.8 instead of 10, you will get probably a value which is different from this, but only 2 decimal places. And if you use 1 gram per cc, you will get gamma W in gram per cc. The unit weight at 50% or 50% degree of saturation, 0.5 is equal to S, is the third question. So we have our basic relation, gamma equal to G plus SE by 1 plus E multiplied by gamma W. Now again, this was the same equation at S is equal to 0, or dry unit weight. In the third question, it is not the dry unit weight, instead the unit weight at S is equal to 0.5. So you can substitute S is equal to 0.5 and you will get the unit weight as around 17.85 kilonewton per meter cube. Again, you can try to work this problem on your own and try to see if you are getting a value similar to the ones that are displayed in the PowerPoint. Question number 5 is an assignment. You have a soil sample which is partially saturated. Its natural moisture content is 22% and the bulk density is 2 gram per cc. If the specific gravity is 2.65, you're asked to find the void ratio E and the degree of saturation S. So try to work this problem on your own and submit as an assignment. Question number 6. The natural soil sample has a bulk density of 2 gram per cc with a water content of 6%. You're asked to calculate the amount of water required to be added to 1 meter cube of soil to raise the water content to 15% while the void ratio remains the same. What is then the degree of saturation? You're asked to take the specific gravity as 2.67. Now, though this question is not a direct application of any of the equations, once you understand the proper concept of a three-phase system diagram, you'll be able to solve this. Now, the basic approach to this question is quite simple. You are given with, let's say, a soil sample whose bulk density is 2 gram per cc, which means it has solid particles and a certain amount of water, which is specified as 6%. Now your task is to find the amount or the volume of water that has to be added to this mixture so that the water content is 15%. The data given in the question is written here. Density is 2 gram per cc. Water content is 6%. Specific gravity is 2.67. Now, even if there's a fluctuation in water content from 6% to 15%, one particular thing remains the same: dry density, or rho d remains the same. Now rho d can be found out from this. Rho is given, W is given. Rho d is equal to rho by 1 plus W, or is equal to 2 gram per cc by 1 plus 6% or 0.06. So the value of dry density is around 1.887 gram per cc. Now once you know the dry density and the total volume, you can find the mass of the solid soils. So for 1 meter cube of the soil, which is the target value, you can find the mass of the solid soils equal to volume 1 meter cube multiplied by the dry density. All you have to take care is of the units. You have to have consistent units. So I have converted the volume 1 meter cube into cc, centimeter cubes, since our density is in gram per cc. So I have volume 1 multiplied by 10 to the power 6 multiplied by the dry density 1.887. So the mass of the dry soil is 1.887 into 10 raised to 6 grams. Which means when you take 1 meter cube of this soil sample, you will have 1.887 multiplied by 10 to the power 6 solids and water, whose percentage is 6% now and whose mass is unknown now. Now, the key point in this problem is that the mass of the solids will remain the same irrespective of the water content. And it's already given that the void ratio remains the same, which means you're not squeezing it in, and neither you are making it to get a release. So the density remains the same, and hence the mass of solids will remain the same irrespective of the water content. What is water content? Water content, as per the three-phase system equations, is nothing but mass of water by mass of solid soils. Or cross-multiplying gives you the mass of the water content multiplied by mass of solids, in which mass of solids is already known to us now and water content is already given to us 6%. So in short, you can find the mass of water at 6% water content as MW is equal to 6% or 0.06 multiplied by mass of solids. So you get the mass of water at 6% as 113220 grams. Now the volume of water at this condition will be equal to 113220 cc's, since the water will have a density of 1 gram per cc. So in short, at 6% water content, mass of water is this and mass of solids is this. Likewise, you can find the water content at 15% water content. The mass of water at 15% water content. So mass of water again is equal to water content 0.15 multiplied by mass of solids. So you get 283050 cc's. So the first part of the question is nothing but the difference between these two values. You are asked to calculate the amount of water to be added to 1 meter cube of soil to raise the water content to 15%. So that water content is nothing but the difference, which turns out to be around 169.8 liters of water. So in short, when you have 1 meter cube volume of soil in which mass of solid is 1.887 10 to the power 6 grams, if you add 169.8 liters of water, the water content will increase from 6% to 15%. Now the second part of the question is to find the degree of saturation at 15% water content. Now for that, again, will depend on the basic density equation. Dry density is equal to G by 1 plus E into rho W, in which G is known to us Rho W is 1 gram per cc, rho D is known to us 1.887. So the only unknown turns out to be voids ratio. Solving this equation, you will get the void ratio 0.415. Now, once you know the void ratio, the specific gravity, and the water content, you can use SE is equal to WG equation to guess the degree of saturation. So S is the only unknown, the value of which turns out to be around 96.5% or 0.965. So in short, when you have this condition where 15% is of water content, the degree of saturation is 0.965. Now, like I said, though this question is not a direct application of any of these equations listed in the basic relation, you can actually solve this problem once you properly understand the basic concept of the three-phase system diagram and if you have the ability to analyze the question. So you can solve this question or any questions of this nature once you understand the concept of the three-phase system diagram.